or anything like that. So I came up with the idea of the talk and the title because, like a lot of people, I originally became interested in Ruby mainly for the Rails framework for web development. And the typical stereotype that a lot of people joke about for people that program Rails are hipsters, young people, skinny jeans, hanging out in coffee shops and developing the latest and greatest web apps that we all love. So that's kind of where the talk came about. But really, now I'm more interested in Ruby from its language perspective and all the great tools that are written in Ruby. So we're going to start talking about some of the features that I think make Ruby a great language to write tools in, particularly security tools, and then just kind of cover some of the some apps that are written in Ruby that you probably all have used and know about. So just a little bit about me. Product security engineer at Salesforce. I was a developer for 10 years before switching to application security, so I've done everything from C, C++ through enterprise Java. I'm an OAuth Indy chapter leader. There's 3 of us. So we've been doing that for 10 years. And I'm also a Ruby enthusiast. So let's start with why Ruby. Now, one of the reasons I love Ruby is because it's a very easy language to read and parse by anyone, typically. You can, like any language, you can definitely do obfuscated things and make it look really interesting, but in general, it's really easy to read. So I just came up with some examples of that. So it has a standard where methods that end in a question mark return a Boolean. So this method it's just asking if that object is empty. It has several different iterator styles. So this one just puts hello world 3 times. This one just iterates through an array using a block. So it for each of the numbers in the list, it prints that number. And then an array length. So those are just kind of some simple examples of Ruby syntax. Another interesting thing about Ruby is that everything is an object, as opposed to some other languages that have, like Java, C#, that have primitives that are wrapped in other objects in order to make them objects. So you can do some really interesting things with that too. Package management. Ruby has a really good package management system called Ruby Gems. So Ruby Gems are either Ruby source that are packaged as libraries, or native source in whatever language that are compiled when you install them for whatever platform you're on that targets that. So it's super easy to actually contribute and create a gem, as well as pull down and use them in your application. It also has an awesome, it's a gem called Bundler that bundles together and allows you to list the gem dependencies of your application, so that when you download a Ruby app, you can just do bundle install, and it will go through and figure out everything it needs and download them and install them for you, which is really nice. So, like most scripting languages, Ruby has very powerful introspection and object-oriented capabilities. Like I mentioned, everything's an object. You can do everything that you would typically think of from an introspection standpoint, as far as finding out information about classes, methods, members, anything like that. You could dynamically create classes, methods, pretty much anything you can do with that. As well as has a really cool thing called object space, which lets you iterate through the entire universe of objects that are created that are running within your Ruby instance, and then do fun things with those. So that's kind of fun. So platform independent support for multi-threading. So Ruby leverages the native threading features of the OS, which is nice. And so that's, for example, on Windows, that's superior to the conventional forking model, which Windows lacks. So it will use the multi-threading features of the platform that you're on, like fibers and threads and things like that for Windows, and other things for other languages. So it can be compiled and run natively on most platforms. It doesn't require things like Cygwin and other dependencies to run, like Perl and other things do. So that makes it really nice. It's really easy to build on anything. It's also easy to embed within other applications. So it has it gives you the header files, the C header files that you can use and then link to it, so you can actually embed, have a Ruby instance running within your application, or you can do things like that. Has a very robust standard library. At the time I did these slides, there were almost 21,000 functioning classes that are really well documented, and there's lots of apps that you can use to look at them. There's like Dash is a Mac app that will let you download docs from many different languages, not just Ruby. There's OmniRef, which is an online one. The Ruby doc system in general is great. And then there's RI, which is a document generator for their platform too. So when you install these by default, any gems and things like that, documentation is built for you and is accessible locally, which is nice. So it's easy to extend existing classes to meet new classes. So, called open classes, which in general programming, you can argue that that's not a good thing because you can do some really convoluted things. But you can also do some really interesting things, and a lot of frameworks in Ruby leverage that, like active support is one that I can think of that does that. So I just have like a quick example slide, I guess, here. So I just drum this up. So first of all, you require the base64 PAP module or gem. You create a string called hack all the things, and then you can see that you do should have put line numbers. The puts s.base64, you can see that the method's undefined for the string. Now string is a built-in Ruby class. So then you can see kind of down here, open the class, add the base64 method and try it again, and then that's available to all string instances from that point on. So it's easy to do things like that. Active support does things like date manipulation and things like that. It adds to the date classes, which is kind of interesting. So it's easy to hook native libraries. So there's the FFI interface to interface with libraries that expose themselves via a C-style interface. So DLLs on Windows or shared objects on Unix. DL is an open bridge, a bridge to DL open for Unix platforms. And it's also easy to extend using C. So not only can you embed Ruby within your within an application, you can also extend it using native code to do fun things. So it lends itself to domain-specific language creation. So domain-specific language is a language designed specifically to express solutions for a problem in a specific domain. And here's some examples of ones that you probably used in Ruby. So Sinatra, which is the DSL that allows you to define how you handle HTTP requests within your application. Chef, used for automating server management tasks. RSpec, which is another DSL for testing. And then active record migrations, if you've seen those. Those are a DSL that help you set up your database and do rollbacks and things like that. IRB. So IRB is the Ruby shell, which is really awesome. So it's a REPL for programming in Ruby. So that's read, evaluate, print, loop. So that allows you to execute Ruby commands within a shell, get immediate response. So if you're testing something, you just want to play with it. And you can do everything in that you can do within a typical Ruby app. So blocks, mixins, monkey patching, which is kind of what we did with the base64 thing, or open classes. So it's really great. It's really full function what you can do in that. So Ruby's also very strong at binary string processing and pattern matching. So you can do, typically a lot of security testing involves creating binary things, sending them over a socket, fuzzing, seeing what comes back. So its support for encoding and native regular expressions built in is really powerful for those types of things. So you can do, string encoding and Unicode support per string or per class, and you can really tweak it. Ruby has first-class regular expressions borrowed from Perl, and it's built in without needing to include extra things. Has a wide support for network protocols and file format parsing. So most of the standard network protocols are built in, and everything else is typically available as a gem. So if you want to look at different document types, different protocols, it's typically pretty easy to add. It has pretty comprehensive OpenSSL bindings. that exposes a huge portion of the OpenSSL API, more than that's available through most other languages like Python and other scripting languages. So that's one example I could think of that I used that was to write a Ruby app that would go through and check all the ciphers that a server supported, and it was a lot easier to do it in Ruby than other things. So it's a module built into Ruby, so it gives you a lot of functionality with that. So now let's kind of switch over to talk about projects using Ruby. So of course the first one that everybody has heard of probably is Metasploit. So Metasploit was originally written in Perl and ported to Ruby in 2006. And I asked some of the team why they decided to do that, and that's kind of the input that some of the previous slides, but I'll just kind of talk about it here again. The platform independent support for threading, has a native interpreter for Windows, which was big back then. And actually the most overwhelming thing or most common thing that they said was that it was the language that most of the people that contributed to the Ruby or to the Metasploit platform enjoyed using. So that's a big thing, if developers like using it. Then there's Metasm, which is it's actually part of the Metasploit project now, but it's a assembler, disassembler, compiler. Lets you do lots of interesting things with binaries and creating payloads and things like that on the fly. Ronin. So Ronin's a platform for vulnerability research and exploit development. There's lots of cool sub-projects that do everything from database access, web scraping, exploit crafting, SQL injection. There's one that'll generate SQL injection strings based on its own DSL that you can do fun things with and target towards specific databases. Ruckus, it's a network protocol fuzzer basically for Ruby. So you can define structures like you're doing them in C, like when you think of your standard protocols, and then it has built-in mutators to fuzz based on those definitions. Beef, so the browser exploitation framework is also written in Ruby, and that's a pen testing tool that focuses on the browser. So it has a Ruby server component, and then you include the JavaScript in whatever payload or whatever site you want to use it, and that communicates back and forth with the server. It allows you to do really interesting and fun things. So, try it out, hook your friends, with permission, of course. Gauntlet. So Gauntlet is a DSL based on Cucumber for interfacing with popular testing tools. So this allows you to define your test cases and run them to do things like parse Nmap results, scan things, and do a whole bunch of interesting things with that. It's very scriptable. PE dump, which supports, so it dumps and lets you look at and evaluate, the Microsoft executable formats, the MZ, the old school DOS type executable, and then the PE, the new portable executable. So you could, dump and inspect every part of that and do interesting things with those. There's a Ruby black bag, which is based on the Matasano black bag. More miscellaneous pen testing tools. That and Ronin go together pretty nicely as far as what they can do. Ragweed, it's a scriptable debugger that works on most major platforms. So it allows you to do really interesting things with that, to debug native applications using Ruby. Packetfoo is a mid-level packet manipulation library that lets you do anything with packet manipulation, kind of like Scapy for other platforms you may have seen. Arachni. So Arachni is a pretty popular web application security scanner framework. Has multiple ways you can use it. There's a command line interface, a web interface, distributed. So if you have multiple Arachnis running, you could coordinate your checks with them. There's, like it says, there's extensive security checks, and you can do cool things with automation and distributing. Has a very powerful JavaScript and DOM debugger. That's really nice. And then Brakeman. Now, I mentioned this because I'd say it's arguably the most powerful and popular open source static analysis tool for a language. So this was designed by the people at Twitter, and then they open sourced it, and now there's also a Brakeman Pro that some people are developing that adds services on top of that. But it's a vulnerability scanner, static analysis for Rails. There we go. WP Scan, it's a really popular WordPress vulnerability scanner. Can do interesting things, enumerating plugins, brute forcing logins, all those type of things. So if you have a WordPress instance, I would definitely run this against it and at least give you an idea if there's anything obvious that's vulnerable. And then Rails Goat. So there's an OWASP project called WebGoat. That's a kind of a deliberately vulnerable web application that you can use for testing. Playing around with different types of attacks, doing things like CTFs and just learning in general. So Rails Goat is the Rails version of that. So it kind of targets Rails and does a lot of the same things. So it's really interesting to use that if you want to, test out Rails security as well as just your own skills as far as assessments. So I think that's it. Are there any questions? Yeah. Yeah, there's the ones I like. There's a book called The Well-Grounded Rubyist. There's also the old Pickaxe book, which was written by Dave Thomas and the Pragmatic Programmers. There's also one focuses on Rails that was written by him and David Heinemeier Hansen, the creator of the Rails project. So those are a couple that I can think of. But I could probably come up with some more too. But those are just what comes off the top of my head. Anybody else? All right, well, thanks.